Okay, I am going to share the screen. Friends, here I shared the document Word file. You are able to see the shared document. Friends, you are able to see the shared document. Please, anyone can reply me. You see the shared
Yes,
document?
sir.
Yes, Rutuja, thank you, thank you. Very nice. Friends, today, as I said in last lecture yesterday, from today we are going to teach actual the syllabus. In before 3 to 4 lecture, we studied the syllabus in detail, and after the discussing syllabus in detail, we are going to see the first unit, and the topic of the first unit is the superposition of the harmonic oscillation. Friends, in last year we know that the wave and oscillations, and oscillation is the to and fro motion of the body. To and fro motion of the body about the mean position is known as an oscillation. But for the oscillation, there is the requirement of the force, and if you consider that is the simple pendulum, and it will be fixed to rigid support, and it will be suspended, and if it is stable at mean position, and if we apply the force and pull on one side and it release, then that simple pendulum can be oscillate about the mean position. That position, that oscillatory motion is the to and fro motion. Means about the mean position, the oscillation will be to and fro. या बाजूला आणि त्या बाजूला. That is to and fro motion will be started, and such a to and fro motion about the mean position is known as an oscillatory motion, and that motion is known as an simple harmonic motion, and it is simply known as an SHM. SHM is the wave, it is the sine wave, but we know that if the simple pendulum is suspended, if we pull that simple pendulum on one side and release, then simple pendulum will be oscillate about the mean position, and the distance traveled, displacement of the simple pendulum from mean position, that will be known as an displacement. Okay, and that is the amplitude means that the simple pendulum will be travel the total distance, that will be known as an amplitude. But as we pull and release the simple pendulum, the amplitude of the simple pendulum will be decreases slowly. That is the in each oscillation, in after each number of oscillation, the amplitude will be decreases slowly, and after some time, after number of oscillation, that is again system came to, that is the simple pendulum came to the mean position. Means that in oscillatory motion, amplitude of the oscillatory body is not constant. That is, amplitude of the oscillatory body will be decreases slowly with the number of half oscillation or the number of oscillation. After some oscillation, after some oscillation, oscillatory body will be diminishes. It will be, it will be its amplitude will be decreases to zero and again came to the mean position. It means that, in oscillatory motion, in oscillatory motion, बोल बा, ठीक है, ठीक है, ठीक है, ओके, ओके. फ्रेंड्स, विद्यार्थ्यांचे फोन असतात, ऑनलाईन मध्ये काही प्रॉब्लेम्स येतात मित्रांनो. रिसीव्ह करणं गरजेचं असतं कारण एक्झाम सध्या सुरू आहे. त्याचबरोबर आपलं ऑनलाईन टीचिंग पण सुरू आहे. ओके, लिव्ह इट. दॅट इज that oscillatory motion, that is to and fro oscillatory motion, its amplitude will be decreases after some, म्हणजे its amplitude will be decreases in each oscillation and slowly its amplitude will be decreases. As we see that here, consider this is the simple pendulum, and if we oscillate the simple pendulum, then its amplitude will be decreases, and that amplitude will be known as an, see here, just I take the animations. Wait. ओके फ्रेंड्स, हरकत नाहीये. आपण इथं मी तुम्हाला मगाशी जस्ट जसं दाखवलं, सिंपल पेंडुलम स्थिर आहे, त्याला आपण मेन पोझिशन म्हटलं. तो एका बाजूला ओढला आपण आणि सोडून दिला तर तो काय होतो, दोन्ही बाजूला अबाउट मीन पोझिशन तो ऑसिलेट होतो. पण त्याची जी अँप्लिट्यूड आहे ती अँप्लिट्यूड प्रत्येक वेळेला काय होते, कमी 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 होते आणि लास्टला तो काय होतो, इट विल बी डॅमिशेस इट्स ऑल द अँप्लिट्यूड. that amplitude of the oscillatory motion become zero. Such a type of oscillatory motion is known as a simple harmonic motion. We know that the linear simple harmonic motion, that is the linear simple harmonic motion, is known as an SHM. And we in last year, that will be, we know that there is one of the equation, and that equation will be known as an, that is the differential equation for the motion. आणि ते काय असतं, that is SHM, it represent by the homogeneous linear differential equation, that will be known as an homogeneous linear simple differential equation. आणि differential equation काय दाखवतं, that is d2y by dt square is equal to minus omega square y, omega square y. It means minus sign का असतं सांगा, that will be the force. आणि कुठला फोर्स आहे तो, that is the restoring force. आणि restoring force ची displacement, that is the direction of the restoring force आणि direction of the displacement are in opposite direction. आणि opposite direction असल्यामुळे इथं काय दाखवलेलं आहे मित्रांनो, here we see the, that is the minus sign. That is the differential equation काय आहे, d2y, y is the displacement, d2y by dt square is equal to minus omega square y, and minus sign is due to the restoring force, because in oscillatory motion the restoring force and the displacement are in opposite direction, and due to that the minus sign is written. See here, where the force d2y by dt square is acting on the particle is proportional to the displacement. We know that that force is known as a restoring force, and restoring force is proportional to displacement. If the displacement is the large, the force is the huge. म्हणजे फोर्स जर मोठा असेल, मी जर जोरात ढकललं तर डिस्प्लेसमेंट मोठी मिळणार आहे, मी हळूच ढकललं, हळूच पुल केलं तर डिस्प्लेसमेंट कमी होणार आहे. मीन्स दॅट the d2y by dt square is the force acting. That force is known as a restoring force, and we know that that restoring force is depend upon the displacement. It will be proportional to displacement y from the mean position, and it always directed toward the mean position, and which is shown by the negative sign, means that if I pull the system मी जर काय केलं, सिंपल पेंडुलम पुल केला आणि सोडला तर तो पुन्हा इकडे येत नाहीये, पुल केलेल्या डायरेक्शन मध्ये येत नाही. तो रिलीज केला की तो मागे मीन पोझिशन कडे जातो. म्हणजे माझं डायरेक्शन ऑफ द पुलिंग मीन्स द डायरेक्शन ऑफ द अप्लाइंग द फोर्स and direction of the displacement are in opposite direction. And friend, the direction of the application of the force and the direction of the displacement are in opposite direction, then that will be shown by the negative sign, and here the negative sign will be shown. Important property of such a homogeneous linear equation, we know that is d2y by dt square is equal to minus omega square y. This is the homogeneous linear equation. And what are the properties of the such a homogeneous equation we are going to see. And one is the each homogeneous solution has two solution. बघा, important property of the such homogeneous linear equation is that the sum of any two solution is also solution. What is the property of the homogeneous equation? The homogeneous linear equation has different solution. If we take the logical sum of two solution, जर हा d2y by dt square is equal to minus omega square y ह्याचे जर सोल्युशन मी दोन कन्सिडर केले, if the y1 is the one of the solution, y2 is the another solution, then I take the summation of the y1 plus y2, that is y is equal to y1 plus y2. If I take the summation of two solution, then summation of two solution is also solution in case of the linear differential equation or homogeneous linear equation. Friends, here the property of homogeneous linear equation is that the homogeneous linear equation has different solution. If we take logical addition of two solution, then that two solutions if added and third solution we get the third solution, that third solution is also solution of that equation. This is the one of the property of the linear homogeneous equation. It means that if we consider in simple language, y1 is the one of the solution of the homogeneous linear equation, again y2 is the one of the another homogeneous linear equation, then if we take the logical addition of the y1 and y2, that is y1 plus y2, and it will be considered as y, then y is also the solution of the homogeneous linear equation. This is one of the property of the homogeneous equation in mathematics, friend, and this property is used as the superposition theorem. See here, the important property, again I will be showing here, the important property काय आहे बघा, what is the important property? The important property of such a homogeneous linear equation is that sum of any two solution is also solution. Sum of two solution is also solution when particle is subjected to two simple harmonic oscillation simultaneously, then the resultant displacement is given by. Consider that simple pendulum is subjected by two forces. दोन फोर्सेस त्याला अप्लाय केले, one is from this direction, other is from this direction, then the resultant displacement of that oscillatory body, the resultant displacement of that oscillatory body is the summation of the displacement of each force. इकडून x अप्लाय करतोय, इकडून y अप्लाय करतोय, या डायरेक्शन मधून x अप्लाय करतोय, या डायरेक्शन मधून y अप्लाय करतोय, आणि then what is the resultant displacement of that simple pendulum is the logical addition of the displacement which was made by each force. Means that जर या डायरेक्शन मधून करतोय ती y1 असेल, या डायरेक्शन मधून जो फोर्स अप्लाय होते त्याची y2 असेल. If the y is the resultant, then y is the resultant, it will be given by the equation y1 plus y2. y1 plus y2 is the resultant displacement of that oscillatory body, where the y1 and y2 are the displacement produced by individual simple harmonic motion. Individual simple harmonic motion. That means the y1 will be the displacement made by the force which was acting in this direction. y2 will be the displacement which was made by the force acting in this direction. Then y1 plus y2 is the resultant displacement that will be shown by this equation. Again friends, this is known as an principle of the superposition. This is known as the principle of superposition. It shows that the resultant displacement, it is the logical addition of the displacement which are produced individually by each force. Individually by each force. Here we considering the two actual restoring force are applying, that will be subjecting on a simple pendulum, then the resultant displacement is the logical addition of the displacement are made by subjecting each force individually. Subjecting each force individually, then the resultant displacement y is equal to y1 plus y2. Then where, that is the read the next line, where the y1 and y2 are the displacement produced in individual simple harmonic motion, and this is known as the principle of the superposition theorem, which is possible only in case of the homogeneous linear equation. Here clearly understand that the principle of the superposition of principle of superposition, that theorem will be only applicable in case of the homogeneous linear equation. That can't be satisfied, that can't be possible in other case, like non-homogeneous equation, like non-linear equation. See clearly, read clearly. That is the principle of the superposition theorem is only applicable, is only possible in homogeneous linear equation. It means that it is not possible in non-homogeneous, non-linear equations. It is only possible in homogeneous and linear equation, not be possible in non-homogeneous non-linear equation. Clearly understand it. That is the equation number 1, that is d2y by dt square is equal to minus omega square y plus c. It may be c may be 0 here, and such a equation is known as an homogeneous equation or homogeneous linear equation. And in only this equation, in only such a type of equation, the superposition theorem, that is the principle of the superposition theorem, is applicable or it will be satisfied. In other equation, it is not possible. Means that in other equation like non-homogeneous and non-linear equation, it is not be possible. The resultant motion of the particle traces the curve. Here, here the resultant, here the resultant motion of the body, motion of the oscillatory body about the mean position is not a straight line. It will be the curve. And that curved path, that curved path will be known as an Lissajous figure. And we get the Lissajous figure, and Lissajous figure is the path of the motion of the oscillatory body in SHM, and that path is not a straight line in case of homogeneous linear equation, friends. And that path which was curved path is known as an Lissajous figure. Lissajous figure is the one of the method to trace the path of the oscillatory body in case of SHM. Understand it? What is important? That is the path is important. Path of the oscillatory body in case of SHM is very important, and that path is neither a straight line or neither a fixed curve. That curve is like a Lissajous figure, and hence that curve is known as the Lissajous figure. And Lissajous figure ओके ओके. किती वेळ काय आहे काम आहे काय? होय काय? एक 5-10 मिनिटं थांबायला सांगितलं. थांबू शकतात का विचारा? थांबतात ते. ओके बसा म्हणून उघडून द्या. फ्रेंड्स, that path is known as a Lysage's figure. We know that the shape of the Lysage's figure, Mitrano, the shape of the Lysage's figure is the oval type. It is not a circle, but it is like a ellipse. If there are the two Lysage's figure, that is the shape is like English 8, like English 0. इफ दॅट इज ट्रिपल ट्रिपल असेल तर तिथं काय होईल, अगदी लूप चेन सारखं आपल्याला इक्वेशन मिळतं. जसं मी सांगितलं 8 आणि तिसरा असेल तर 8 ला आणखीन खाली असेल. सच अ टाइप ऑफ लिसाइजस फिगर that will be known as an oscillatory motion. That is, the shape of the Lysage's figure is depend upon the frequency. The shape of the Lysage's figure is depend upon the frequency, amplitude, and phase difference of the two consecutive simple harmonic motion. There are the two forces are subjecting on the oscillatory body. There are the two types of the motion. The resultant motion is the addition of the two displacement, and here the shape of the Lysage's figure is depend on the amplitude of the oscillatory motion, the frequency of the oscillatory motion, and phase difference of the oscillatory motion. On these three things, on these three physical quantity, the shape of the oscillatory motion, that is the shape of the Lysage's figure, is depend. And if one of the quantity will be changed, if the frequency will be changed, Lysage's figure will be going to change. If only path difference will be changed, the Lysage's figure will be changed. It means that the curved path of the oscillatory body, that will be known as an Lysage's figure. That shape of the Lysage's figure is depend upon the amplitude, frequency, as well as the path difference in between two constant simple harmonic oscillation. And the study of the Lysage's figure gives the useful comparison of the frequency. Means that just we studying the shape of the Lysage's figure, one can able to compare the frequency of the both the forces, the frequency of the both the oscillatory motion. Means that just by studying the Lysage's figure, one of the physicist, one of the person which is able to compare the frequencies of the two oscillatory motion. Friends, the linearity and superposition principle, that is the what is the statement of the superposition principle, superposition theorem. In case of oscillatory motion, is there a simple harmonic motion is generally represented by the differential equation which is given by dabba 2y by d2y by dt square is equal to minus omega square y. This is the generalized equation of the displacement equation which is used to calculate the restoring force, and this equation is the very general equation, that is d2y by dt square is equal to minus omega square y, where the restoring force is depend upon the displacement, that is restoring force d2y by dt square, that will be totally depend upon the displacement, that is the y is the displacement. And we know that that is the y, but it does not depend upon, it does not contain, this equation does not contain the higher power of the y. Higher power of the y आहे का मित्रांनो? No, that is the single power of only y आहे, d2y. y ची तर पॉवर आहे का जास्त नाही आहे, that is d2y by dt square is equal to minus omega square only y. y square आहे का? नाही. y cube आहे का? नाही. y raised to 4 आहे का? नाही. y raised to 5 आहे का? नाही. Means that the all the higher power terms in terms of the y square, y cube, y4 हे सगळं इथं काय केलेलं आहे? डिलीट केलेलं आहे. मीन्स दॅट this term of the higher power of the y will be ignored. Such equation is called as a linear equation. Which is the linear equation, Vaibhav? Vaibhav, linear equation is the equation in which the higher power of the y will be ignored, higher power of the y will be deleted. That will be known as a linear equation, and such a linear equation will be known as a linear homogeneous equation, because that is the addition of two solution is also solution. Addition of two solution or the logical sum of two solution is also solution of that equation. That will be known as the homogeneous linear. When linear, that is the power of the y not higher, that is y square, y cube, y4 or dot 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 is not present, that is linear. And if that is the two different solution are added, that addition is also the solution of the equation, it will be known as an homogeneous equation. Means this equation is homogeneous as well as the linear equation, hence it will be known as an homogeneous linear equation. Hence the equation which contain the higher order of the term y, means if the equation contain y square, y cube, y raised to 4, then that equation will be known as a non-linear. Means that above equation is linear, not non-linear, because it does not contain the higher power of y. Secondly, we notice that equation number 1 म्हणजे above equation does not contain the independent of the y is independent. Here we see that both the term on left hand side and right hand side, that is d2y by dt square in left hand side, and right hand side, that is minus omega square y, both the term are depend upon the y. Independent term आहे का प्लस के प्लस सी प्लस ए प्लस बी असं काय आहे का इथं नाही आहे. म्हणजे in equation each and every term is depend upon the y, is not independent on the y. If the equation is homogeneous linear, that is the linear because the higher terms are deleted, and if the variable term is dependent, see here it is not independent, म्हणजे काय आहे, it is dependent आहे. आणि if the variable term is dependent, then that equation is known as an homogeneous equation. Why above equation is homogeneous and linear? Because that is linear, it means that in which higher terms are deleted, and again that equation is homogeneous because, what is the reason? Because the variable is dependent, not independent, it is dependent, and hence it is called as an homogeneous linear equation. If the equation contain the term independent y, then that will be known as a non-homogeneous. Friends, see here the only difference between homogeneous linear equation and non-homogeneous non-linear equation. This is the difference. Important property of the homogeneous equation is that, what is property? Property of the homogeneous equation, sum of two solution is also solution. Sum of two solution is also solution of that equation. That is the sum of two solution equation in one are homogeneous linear equation, means it is also the solution. See here, the principle of superposition states that when the particle is subjected, to the two simple harmonic motion simultaneously, then resultant y is a vector sum of individual displacement of the two solution, or the two displacement which is made by individually by two different forces. That is the y vector is equal to y1 vector plus y2 vector. It is the important, what is the statement of the superposition theorem? The superposition theorem states that when particle is subjected by two simple harmonic motion, that is the simple pendulum is subject by two different directional forces. one in x direction, other in y direction. Then if the particle is subjected to the two simple harmonic motion simultaneously एकाच वेळेला, then the resultant displacement y vector is the vector sum of individual displacement of individual displacement produced by each forces separately. That is y1 vector and y2 vector are the individual displacement produced by each forces individually. Then what is the resultant displacement? The resultant displacement is the y1 vector is equal to y1 vector plus y2 vector. That is y vector is y1 vector plus y2 vector, and this is the homogeneous statement, mathematical relation of the homogeneous simple that will be known as a superposition theorem. That is the y vector is equal to y1 vector plus y2 vector. That is the y1 and y2 are the, here friends, y2 is necessary. That is the y1 and y2. y1 and y2 are the y1 and y2 are the individual displacement produced by the each force separately. आणि आपल्याला हा प्रूव्ह करायचं असेल, that is the important to note that only homogeneous linear equation आपल्याला हे ओबे करतं का? That is the principle of the superposition of theorem can obey the homogeneous linear equation. हे आपल्याला इथं प्रूव्ह करायचं. काय प्रूव्ह करायचंय? That is the principle of the superposition can satisfy the condition of homogeneous linear equation. होमोजिनियस लिनियर इक्वेशनची कंडिशन मित्रांनो सॅटिस्फाय होते की नाही, किंवा होमोजिनियस लिनियर इक्वेशनची कंडिशन हे इक्वेशन सॅटिस्फाय करतं की नाही, हे आपल्याला इथं बघायचं आहे. आणि जर कंडिशन सॅटिस्फाय केली तर त्याला काय म्हणायचं? सुपरपोजिशन प्रिन्सिपल हे काय करतं? लिनियरिटी काय करतं? एक्सप्लेन करतं. किंवा होमोजिनियस लिनियर एक्सप्रेशन काय करतं? सॅटिस्फाय करतं. असं आपल्याला इथं म्हणता येईल मित्रांनो. म्हणजे आपल्याला काय करावं लागेल? मॅथमॅटिकल प्रूफ द्यावं लागेल की सुपरपोजिशन प्रिन्सिपल हे लिनियर होमोजिनियस इक्वेशन सॅटिस्फाय करतं. लिनियर होमोजिनियस इक्वेशन सॅटिस्फाय करतं हे आपल्याला मित्रांनो सांगावं लागेल. आणि हे जर सांगितलं तर निश्चितपणे आपल्याला काय होतं मित्रांनो सांगा? दॅट विल बी दी टोटल linearity condition and simple that is the principle of the superposition theorem या कोरिलेट होतील. यासाठी आपल्याला मॅथमॅटिकल एक्सप्रेशन घ्यावं लागेल. इथं बघा, टू प्रूव्ह दी अबाव स्टेटमेंट लेट अस कन्सिडर दी नॉन होमोजिनियस नॉन लिनियर डिफरन्शियल इक्वेशन आहे. नॉन होमोजिनियस का तर y ची पॉवर वाढणार. नॉन होमोजिनियस नॉन लिनियर that is d2y by dt square is equal to a minus omega square y plus by square स्क्वेअर आला बघा, प्लस सी वाय क्यूब आला बघा, प्लस डी वाय रेस टू 4 आला. म्हणजे नॉन लिनियर आहे, नॉन होमोजेनियस आहे. y1 आणि y2 जर दोन आपल्याला काय दिसत आहेत? y1 आणि y2 आर द टू डिफरन्शियल सोल्युशन ऑफ द डिफरन्शियल इक्वेशन 2 आहे. ह्या टू इक्वेशनचे दोन सोल्युशन असतील तर आपण एक सोल्युशन पहिल्यांदा y1 घेतलं तर y च्या ठिकाणी y1 पुटअप करा. y च्या ठिकाणी y1 पुटअप केल्यावर इक्वेशन काय होतंय बघा? that is d2y1 by dt square is equal to a into minus omega square y ऐवजी y1. that is the plus b into y square ऐवजी y1 square plus c into y cube ऐवजी cy1 cube आणि d raised to y raised ऐवजी dy1 raised to 4. आपल्याला 3 नंबरचं इक्वेशन मिळेल. जसं y1 सोल्युशन आहे तसं y2 आहे, त्यामुळे हे इक्वेशन y2 ला सुद्धा सॅटिस्फाय होणार. त्यामुळे या ठिकाणी जिथं y असेल त्या ठिकाणी मी y2 पुटअप केला बघा. y2 that is the d2y2 divided by dt square is equal to a minus omega square. इथं काय आहे मित्रांनो? इथं y2 पाहिजे होतं, इथं मी y2 देतोय. इथं आपल्याला y2 पाहिजे होतं मित्रांनो, इथं तेवढं y2 मी पुटअप करतो. इथं y2 पुटअप केलं मित्रांनो. यस, y2 इथं पुटअप केलं. that is omega square y2 plus b d into y2 raised to 2 plus c into y cube म्हणजे y2 raised to y cube प्लस d into y2 raised to y4. म्हणजे मी काय केलं बघा, जिथं जिथं y होतं तिथं y1 एकदा पुटअप केलं, इक्वेशन 3 मिळालं. त्याचबरोबर y2 पुटअप केलं, मला इक्वेशन काय मिळालं, 4 मिळालं. If the principle of the superposition is the true, what is the statement of the superposition principle? It says that if the y1 and y2 are the two solution, then the resultant, that is the, if we take the addition of these two solution, that is the resultant of these two solution is also true. आणि मी जर y is equal to y1 plus y2 असं म्हटलं, तर this relation will be also true for the y. This solution, that is this equation is also true for y is equal to y1 plus y2. मित्रांनो, जसं y च्या ठिकाणी मी y1 आणि y2 पुटअप केला, तसं y च्या ठिकाणी आता मी काय पुटअप करणार आहे, y1 plus y2 पुटअप करणार आहे. that is dabba 2y by dabba t square, that is d2y by dt square is equal to d square into y1 plus y2 divided by dt square a into minus omega square y1 plus y2 plus b into y च्या ऐवजी मी काय करतोय, y1 plus y2 क्यूब स्क्वेअर घेतला बघा, c into y1 plus y2 क्यूब घेतला, d इज इक्वल टू y1 plus y2 4 घेतला, डॉट 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 मिळालं, मला इक्वेशन 5 मिळालं. आता ऍडिशन करतोय मी, 3 आणि 4 ची ऍडिशन केली की काय होईल बघा, d2 y1 by dt स्क्वेअर प्लस d2 y2 by dt स्क्वेअर म्हणजे y1 plus y2 मिळेल. 2 मिनिटं थांबा, झालं, बंद केले. दॅट इज ह्या दोघांची मी ऍडिशन घेतली तर इकडे काय ऍडिशन मिळते बघा, मला 2a, पुढे काय मिळतंय बघा, यातनं ओमेगा स्क्वेअर मी दोघांच्यातनं कॉमन घेतला, y1 प्लस y2, b कॉमन घेतला, y1 स्क्वेअर y क्यूब स्क्वेअर. पुन्हा मी काय घेतलं बघा मित्रांनो, इथं मी काय कॉमन घेतोय बघा, या म्हणून वर्गातच जाऊ काय, ओके मित्रांनो, तर स्क्वेअर आहे एवढं लक्षात ठेवा. पुढे जाऊन आपल्याला काय मिळतंय बघा, या दोघांची मी ऍडिशन केली की मला काय मिळतंय, y2y बाय म्हणजे d2y बाय dt स्क्वेअर बरोबर d2y1 प्लस y2 डिवायडेड बाय dt स्क्वेअर, हे सगळं मिळतंय. आणि नाऊ ऍडिंग इक्वेशन नंबर 3 and 4, हे दोन जर मी ऍड केले तर हा a ऐवजी मला काय मिळतोय मित्रांनो, 2a मिळतोय. आणि हे दोन्ही आपल्याला मी काय करणार आहे, पुढच्या पिरियडला कम्पेअर करून सांगणार आहे. आणि कम्पेअर केल्यानंतर सुपरपोजिशन प्रिन्सिपल कशा पद्धतीनं होमोजिनियस आणि लिनियर आहे हे मी तुम्हाला कम्पेअर करणार आहे. प्लीज चॅटबॉक्स मध्ये सगळ्यांनी परत एकदा अटेंडन्स द्या. आणि आता मी जे सांगितलं त्याच्याबद्दल काही कन्फ्युजन असेल, काही शंका असेल तर विचारा. आपण मीटिंग एंड करणार आहे. प्लीज गिव्ह दी अटेंडन्स, सबमिट द अटेंडन्स इन चॅट बॉक्स. Friends, please submit the attendance in chat box. Today, 42 students are present. Today, 42. At the beginning, there are the 45 students are present. Meanwhile, I feel that 3 students leave the meeting. There may be any problem of the network. Okay. Friends, this lecture will be available. That is, the video of this lecture will be available on the Google Classroom. In 2 to 3 days, I will give the Google Classroom link to you, and all the videos, all the lecture video will be, you are able to see in Google Classroom. Okay, friends? Just I am going to share, save the chat box. Friends, जयश्री बच्चे सगळ्यांनी अटेंडन्स दिला का? जयश्री,
Yes, sir.
व्हेरी नाईस. सगळ्यांनी अटेंडन्स दिला का? अटेंडन्स
Yes,
दिला
sir.
ना? सोनल,
Yes, sir.
व्हेरी नाईस, व्हेरी नाईस सोनल. ओके, आपण उद्या भेटूया. उद्याच्या लेक्चर टाइमची मी लिंक देईन. काय अडचण नाही ना? रसिका, काय अडचण नाही ना?
No, sir.
Okay, okay. Just I am leaving the meeting, friends. Okay, friends? Have a nice day. Stay home